Hello, my name is Ruggerman Hari. My final project is on predicting student dropout risk in training programs as part of the AI Product Management Specialization at Duke University. In this presentation, I'll walk through the opportunity, business understanding, solution validation, system design, potential risks, and conclusion. Let's begin with opportunity evaluation. First, is there a problem? Yes. Many students drop out before completing training programs. This not only impacts their future opportunities, but also reduces placement outcomes and the overall credibility of the program. Second, can machine learning help solve this? Absolutely. We already collect a lot of structured data such as attendance, quiz scores, and many more. With this data, a machine learning model can learn patterns that signal early risk of dropout. And third, does someone care? Definitely. Preventing even 10 to 15% of dropouts has a big impact. Students benefit with better job prospects, trainers can target their interventions more effectively, and the organization strengthens its outcomes and reputation. This in turn increases impact. Here we will discuss our ISPDM business understanding. The problem is clear: students drop out midway, and we need to identify them early so mentors can intervene. Success means fewer students dropping out and more completing the program. The outcome target is to improve completion rate by 15% and reduce dropouts by at least 10%. For output metrics, recall above 0.8 is critical because we don't want to miss at-risk students. As for constraints, we have a few. Interventions require staff time, so predictions must be reliable. The model should be explainable so trainers can trust it, and moreover, student data privacy must be preserved. Factors that may be relevant include academic performance, engagement data, demographics, and behavioral signal. Solution validation plan: the solution concept is a supervised classification model, such as logistic regression or decision trees, to predict whether a student is at risk of dropping out. Features would include attendance, quiz scores, platform usage, demographics, and behavior patterns. The validation approach has many steps. First, test on historical data and compare predictions with actual dropout outcomes. Second, share predictions with trainers to see if they align with their observations. Third, run a pilot with live students, where mentors get alerts for at-risk students and track if interventions reduce dropouts. Finally, retrain the model with updated data and features if performance is below target. We will continue this cycle continues until metrics are achieved. ML system design. We are going to go with cloud and not edge since it needs access to large volumes of historical student data and must be easy to monitor and retrain. Training will be offline, either weekly or monthly, as dropout patterns don't change daily. Predictions will be generated in batch mode, since real-time prediction is not required. Finally, the design will prioritize explainability over raw accuracy so the trainers can understand why a student is flagged, which builds trust and supports targeted interventions. Risks in production. First, data drift. If training shifts from offline to online delivery, engagement patterns may change, requiring retraining. Second, concept drift. Reasons for dropout may change over time. For example, students might leave now because of financial difficulties, but in the future, the main reason could be getting other opportunities like a job offer during the course. Third, bias. The model may unfairly predict higher dropout risk for certain demographics, so fairness checks are important. Fourth, training serving skew. If attendance data is logged differently in real time, predictions may be inaccurate. Latency, however, is not a major issue, since batch predictions are sufficient. To conclude, predicting student dropout risk is feasible because we already have the right data. It's impactful because it directly improves student and program outcomes. And it's a strong ML opportunity because the model can capture patterns that simple rules cannot. With clear success metrics, a robust validation plan, thoughtful system design, and awareness of risks, this solution has strong potential to reduce dropout rates and increase program success. Thank you.